The sun's story begins in a collapsing cosmic cloud where gravity gently gathers drifting dust into a glowing core. As the cloud shrinks, it spins faster, forming a flattened disk of gas and dust that will one day host our sun. Deep in the center, pressure and temperature rise until nuclear fusion ignites, marking the true birth of the sun. In its wild youth, the sun blasts fierce stellar winds that tear through the disk and clear vast paths in space. Those powerful winds sculpt lanes in the disk, carving out regions where the first rocky planets slowly emerge. Over time, the sun calms and settles into main sequence life, shining with a steady golden light that lasts for eons. Its warm rays strike young Earth, helping oceans remain liquid and allowing early life to cautiously take hold. Inside the core, hydrogen fuses into helium, releasing immense energy that powers the sun's constant brilliance. This outward energy flow balances inward gravity, keeping the sun stable and preventing a catastrophic collapse. Across the surface, bright plasma cells rise and sink, creating a mottled pattern of ever-shifting solar granules. Far above, the shimmering corona extends outward, strangely far hotter than the visible surface beneath it today. Constant solar wind streams from the sun, forming a vast heliosphere that shields planets from deadly radiation. When these charged particles strike Earth's magnetic field, vivid auroras ripple across our polar night skies. Dark sunspots appear where twisted magnetic fields cool local regions, marking zones of intense solar activity. Over an 11-year cycle, the sun shifts from quiet phases to stormy periods filled with flares and eruptions. The sun's magnetic field twists and stretches, storing enormous energy that can suddenly release without warning. When this energy snaps free, powerful solar flares erupt, blasting intense radiation across the solar system. Sometimes these eruptions hurl vast clouds of charged matter called coronal mass ejections into space. If aimed toward Earth, these massive plasma clouds can disturb satellites, power grids, and communications. Despite its violent moments, the sun remains remarkably stable, continuing to shine steadily for billions of years. As hydrogen slowly depletes in the core, subtle changes begin that will eventually alter the sun's future. Over billions more years, the sun will grow brighter, slowly warming Earth beyond today's familiar balance. Eventually, the sun will exhaust its core hydrogen, forcing it to expand dramatically into a red giant star. In this red giant phase, the sun may engulf Mercury and Venus, radically reshaping the inner solar system. Earth itself may become a scorched world, stripped of oceans and atmosphere by extreme solar heat. After shedding its outer layers, the sun will leave behind a glowing shell known as a planetary nebula. At the center, the sun's core will remain as a dense white dwarf, slowly cooling over time. This white dwarf will no longer fuse elements, instead fading gradually as it releases its stored heat. Long after life on Earth ends, the sun's remains will drift silently through the galaxy as stellar ash. The sun's full story reveals how stars are born, live, and die, shaping the universe we inhabit. The sun's long, stable life allows planets time to evolve, giving biology billions of years to slowly experiment. Compared to massive stars, the sun lives quietly, avoiding violent supernova deaths that reshape nearby space. This quiet nature makes the sun ideal for life, providing steady energy without frequent catastrophic disruptions. The sun's gravity anchors the entire solar system, keeping planets locked in predictable, stable orbits. Even small changes in the sun's output can influence climate, weather, and long-term conditions on Earth. Scientists study the sun closely, using space probes to observe its surface, winds, and magnetic behavior. Missions like Parker Solar Probe fly closer than ever, revealing details hidden deep within the solar atmosphere. These observations help scientists predict solar storms that could threaten modern technology on Earth. Understanding the sun also helps astronomers understand countless other stars across the galaxy. Our sun serves as a reference, teaching how stars evolve, age, and ultimately meet their quiet ends. Long after humanity is gone, the sun will continue its slow evolution, indifferent to what once orbited it. The sun's future reminds us that nothing in the universe remains unchanged forever. Yet without the sun's steady presence, life on Earth would never have existed at all. The sun is not just a star, but the engine that shaped our planet and every living thing upon it. By understanding the sun's story, we better understand our own place in the vast universe. The sun also influences comets and asteroids, shaping their paths as they travel through the outer solar system. Occasionally, some of these objects are pulled inward, creating spectacular comets visible from Earth's skies. Solar energy strips material from comets, revealing clues about the earliest days of the solar system. Solar energy also drives space weather, influencing conditions far beyond Earth's immediate environment. Understanding space weather helps protect astronauts, spacecraft, and critical systems orbiting Earth. The sun's cycles leave signatures in tree rings and ice cores, recording its history on Earth itself. These natural records allow scientists to trace past solar behavior across thousands of years. The sun's relatively calm behavior contrasts sharply with more violent stars elsewhere in the galaxy. This calmness gives life a rare opportunity to evolve without frequent extinction-level stellar events. As the sun ages slowly, it continues converting mass into energy through relentless nuclear fusion. Every second, millions of tons of matter become light, spreading energy across the solar system. This constant energy flow defines the solar system's environment and powers countless natural processes. The sun's story mirrors that of countless similar stars scattered throughout the Milky Way. By studying the sun, astronomers unlock universal rules governing how stars live and change. The sun stands as a bridge between cosmic physics and the fragile world that depends upon it. The sun's steady output creates predictable seasons, helping Earth maintain long-term climate stability. Small variations in solar energy can subtly influence long-term climate patterns over centuries. Humans have observed the sun for thousands of years, shaping myths, calendars, and early science. Early cultures tracked solar cycles to predict seasons, agriculture, and survival itself. The invention of telescopes transformed the sun into a symbol, into an object of scientific study. Modern observatories now watch the sun constantly, monitoring changes in real time. These observations allow early warnings of solar storms that threaten technology and power systems. The sun also shapes space beyond planets, influencing dust, plasma, and interstellar boundaries. At its boundary, the sun's influence meets material from distant stars and ancient cosmic clouds. The sun itself formed from earlier generations of stars that lived and died before it. Elements forged in those stars now exist within the sun, Earth, and every living thing. In this way, the sun connects cosmic history directly to life on our planet. The sun's future reminds scientists that even stable stars must eventually change and fade. Studying the sun helps prepare humanity for long-term changes within our cosmic environment. The sun's story stands as a reminder that cosmic processes shape both worlds and living beings. The sun's gravity also guides distant icy bodies in the Kuiper Belt, far beyond Neptune's orbit. Beyond that lies the Oort cloud, a distant reservoir of comets loosely bound to the Sun. Occasional disturbances send comets inward, reminding us of the Sun's influence even at extreme distances. As comets approach the Sun, heat transforms frozen ice into glowing gas and dust tails. These comets act as time capsules, preserving material from the solar system's earliest days. Solar gravity also influences asteroid belts, maintaining structure while allowing occasional collisions. Jupiter helps control many asteroids, but the Sun remains the ultimate gravitational authority. Without the Sun's gravity, the solar system would quickly unravel into drifting chaos. The Sun's mass also warps space itself, subtly bending the paths of nearby objects. This bending confirms predictions of relativity, linking the Sun to fundamental laws of physics. The Sun therefore serves as a natural laboratory for testing physical theories. Observing the Sun improves our understanding of stellar behavior across the universe. Many stars share the Sun's fate, living long, stable lives before quietly fading away. The Sun is therefore not unique, but it is uniquely important to everything we know. Its influence reaches from atomic fusion to planetary climates and the rhythms of life itself. The Sun's energy drives photosynthesis, forming the base of nearly every food chain on Earth. Without this steady sunlight, Earth would freeze, oceans would solidify, and life would vanish entirely. The Sun's position in the galaxy also places it in a relatively calm region of the Milky Way. This quiet neighborhood reduces exposure to radiation from frequent stellar explosions. Our star's moderate size further contributes to its long, stable lifetime. Massive stars burn fast and die young, while small stars live far longer but shine dimly. The Sun strikes a balance, offering both stability and sufficient energy for life. This balance has allowed complex life to evolve gradually over billions of years. The Sun's influence even affects biological rhythms and human health. Humans now seek to harness solar energy directly, capturing sunlight to power civilization. Solar power offers a clean link between our star and a sustainable future on Earth. By studying the Sun, humanity gains insight into managing planetary resources wisely. The Sun's predictable behavior allows long-term planning across generations. Understanding the Sun helps us protect both technology and life from future solar hazards. The Sun remains our most important natural ally in understanding stars and sustaining life. The Sun's predictable rise and set have shaped human timekeeping, calendars, and daily routines for millennia. Solar eclipses remind us of precise cosmic alignments governed by the Sun's gravity. These alignments reveal the elegant mechanics governing motion throughout the solar system. The Sun's light has guided explorers, navigation, and our understanding of Earth's place in space. Modern science decodes sunlight to learn about the Sun's composition and internal processes. Each photon carries information from deep within the Sun, traveling millions of years before escape. The Sun's emissions influence not only Earth, but also the space environment across nearby stars. Our Sun is just one chapter in the galaxy's long stellar story, yet it is uniquely ours. The quiet reliability of the Sun contrasts with the violent lives of massive stars. This reliability has allowed life to flourish without frequent cosmic catastrophes. The Sun's future evolution will unfold slowly, giving advance warning of major changes. By understanding stellar evolution, we can anticipate long-term cosmic risks and opportunities. The Sun connects fundamental physics to everyday experience on our planet. Studying the Sun continues to inspire curiosity, discovery, and technological progress. The Sun's enduring presence reminds us that cosmic forces quietly shape every moment of life. The Sun's long history shows how simple physical laws can create complex and enduring cosmic systems. Gravity pulled matter together, fusion released energy, and balance maintained the sun's steady existence. This balance is fragile, yet it has endured for billions of years without collapsing or exploding. The sun's example helps scientists understand why some stars live long lives while others burn out quickly. Through observation, models, and theory, the sun has become one of the best-studied stars in existence. Each discovery about the sun refines our understanding of stellar physics across the universe. The sun's light also carries information about motion, temperature, and magnetic structure. By decoding this light, astronomers read the sun's internal story without ever touching it. The sun therefore acts as both subject and tool in humanity's exploration of space. Its energy powers not only life, but also exploration beyond Earth's atmosphere. Solar-powered probes venture farther, carrying the sun's influence into distant regions. The sun thus remains central even as humanity looks outward toward other worlds. In learning the sun's story, we learn how stars shape environments where life might arise elsewhere. The sun becomes a template for searching habitable worlds beyond our own. Ultimately, the sun teaches that life and stars are deeply linked through cosmic time. The sun's calm behavior makes it easier to study than distant stars scattered across the galaxy. This proximity allows scientists to test theories that apply to stars everywhere in the universe. By observing the sun, researchers learn how energy moves through stellar interiors. The sun's convection zone churns constantly, moving energy toward the surface. This motion drives surface activity, shaping sunspots, flares, and magnetic storms. Magnetic storms from the sun can compress Earth's magnetosphere and alter near-Earth space. These interactions show how closely linked Earth is to the sun's behavior. Despite this connection, Earth remains protected by its atmosphere and magnetic field. The sun's influence extends gently most of the time, supporting stability rather than destruction. This gentle dominance has allowed complex ecosystems to develop and persist. The sun therefore acts as both a powerful force and a careful guardian of its system. In cosmic terms, the sun represents a common but perfectly placed type of star. Many potential life-bearing systems may depend on stars much like our own. Studying the sun helps narrow the search for life beyond Earth. In this way, the sun guides not only our lives, but our search for life across the universe. The sun's steady glow has guided humanity from ancient survival to modern scientific understanding. From worshipped deity to studied star, the sun reflects humanity's growing knowledge of nature. This shift marks one of humanity's greatest achievements in understanding the universe. The sun's predictable behavior allows scientists to test ideas with confidence and precision. By comparing the sun to other stars, astronomers identify patterns that govern stellar evolution. These comparisons reveal how mass determines a star's life, death, and influence. The sun's moderate mass gives it both longevity and stability, rarely found together. This balance has allowed Earth to remain habitable for billions of years. Even small disruptions to this balance could have ended life's long experiment. The sun, therefore, plays a quiet but decisive role in Earth's survival story. Looking ahead, understanding the sun helps humanity plan for distant future challenges. Long-term knowledge of the sun informs decisions about space travel and planetary protection. The sun's lessons extend beyond science, shaping philosophy and our view of existence. In understanding our star, we better understand our fragile place in a vast universe. The sun's story ultimately reveals how cosmic forces quietly shape life, knowledge, and destiny. The sun's quiet dominance shows that immense power does not always appear violent or dramatic. Its energy flows constantly, shaping environments without drawing attention to its steady work. This continuous flow highlights how stability can be as important as intensity in cosmic systems. The sun's reliability has allowed complex chemistry to unfold across Earth's long history. Over time, this chemistry led to biology, intelligence, and the ability to study the sun itself. The sun thus becomes both creator and subject within humanity's scientific journey. Each generation refines our understanding, building upon centuries of solar observation. This accumulation of knowledge reveals patterns hidden across immense spans of time. The sun's past helps predict its future with increasing confidence. These predictions allow humanity to prepare for changes far beyond a single lifetime. The sun's fate reminds us that even stable stars are temporary on cosmic scales. Yet within that long lifespan, the sun provides a rare window of opportunity for life. This window has allowed humanity to ask profound questions about existence itself. In studying the sun, we connect personal experience with universal physical laws. The sun's complete story shows how a single star can shape worlds, minds, and destiny. The sun's influence reminds us that stability is the foundation upon which complexity can grow. Without that stability, planets would wander and conditions for life would collapse rapidly. The sun therefore acts as the unseen architect of the solar system's long-term harmony. This harmony extends from planetary motion down to the rhythms of climate and biology. The sun's constancy allows feedback systems on Earth to remain balanced over time. Through this balance, life adapts rather than merely survives. The sun's energy also drives long-term geological processes, shaping Earth's surface. These processes recycle nutrients and reshape environments across millions of years. The sun thus influences not just life, but the planet's physical identity itself. Understanding this influence deepens our respect for seemingly ordinary cosmic forces. The sun teaches that power does not always announce itself loudly. In that quiet strength lies the reason life had time to emerge and endure. The sun's example reshapes how we define importance in the universe. Not the brightest or largest, the sun is powerful because of its perfect balance. This balance ultimately made awareness, curiosity, and understanding possible. The sun's balance teaches that long-term influence often matters more than short bursts of extreme power. This lesson applies beyond astronomy, echoing patterns found in nature and human history. The sun's steady rhythm creates a dependable backdrop for evolution and discovery. Because the sun changes slowly, scientists can model its future with remarkable accuracy. This predictive power allows humanity to look far beyond immediate generations. The sun's story connects the distant past with a future that still lies far ahead. Every moment of sunlight carries energy forged deep within the sun's ancient core. This energy has traveled for millions of years before touching Earth's surface. When it arrives, that energy fuels motion, chemistry, and life in countless forms. The sun's influence is therefore both immediate and unimaginably ancient. Understanding this duality deepens appreciation for the hidden complexity of simple light. The sun appears ordinary, yet its quiet consistency is extraordinarily rare and valuable. Without such stability, awareness and reflection might never have emerged at all. The sun's legacy is written not in explosions, but in time, patience, and balance. In the end, the sun shows how a single star can quietly shape an entire world.